Hi students, welcome to my lectures on mechanical unit operations. Today we are going to discuss about the size reduction methods, and I am going to take you to the lab and show you and what are the different crushers or grinders that are available with us. To know about, before we go into the crushers, we should talk something about the size reduction. The other name for the size reduction is comminution. Okay, the object, what is the need for going for size reduction? As you can observe on the board, I have written some important points. Why size reduction? Size reduction has many applications in the industry. One important is increase the surface area. As you break the material into smaller pieces, it will increase the surface area. I mean, imagine I have the particle with me. If I divide this particle into 10 particles, my surface area will be increased. And what is the advantage of increasing of any surface area is, as we are dealing with a number of unit operations and processes in the industry, if the more is the surface and greater is the different aspects like drying, you can dry the material very easily if you increase the surface area. Adsorption is a surface phenomenon. More is the surface, more is the material getting adsorbed on the surface, and better is the separation. Next is reaction, because as you know, in catalysis, for example, there is a catalyst to play an important role. If we provide a more surface area by breaking this material, I can able to increase the reaction rate. Okay, that is the job of reaction. And the other is contact area, because there are number of reasons, because adsorption, surface reactions and desorptions, everything, if we increase the area, that means automatically the efficiency of any process is going to get increased. That is one such an application why we have to reduce the size of the material. And second is, sometimes it is required, I don't want this size, I have to go for this size of the material. Okay, sometimes the size reduction, depending upon the application, maybe desired shape we want, desired size we want. And third is separation of unwanted particles. The separation of unwanted particles means, sometimes if you go to the mining industry, as you iron ore, if you talk about, iron ore won't come in its pure form. Sometimes there is a dust or a rock kind of material will be deposited over the iron ore. So to separate the iron ore from the other unwanted particles, people used to crush these machines, because during the crushing operation, the unwanted material will be break compared to the iron ore. So you can able to separate the unwanted material from the iron ores, because that is why the other application of size reduction is separate unwanted products. Dispose the solid waste. Okay, sometimes if you make smaller particles, it is easy to compress the smaller particles and you can able to dispose the material very easily. Instead of depositing a big volume, if you can able to reduce the volume by making it a smaller size, it is easy for you to dispose the solid materials. And mixing of the solids, if you talk about the talcum powders and any material, if you make it a smaller size, it is easy for you to mix. Okay, so it is important. This is one of the application of size reduction methods, is also for mixing. And easy storage. Okay, it is easy to store in a container rather than the open surface. If you make a smaller material, you can able to store in a small containers itself, so it is better for you, better storage as well as the better transportation. You can easily transport a container from one location to another location consisting of the smaller particles. And the other thing is, as we are talking about the size reduction, okay, how you going to reduce the size of any particle? There are four primary forces that are responsible to reduce the size of the particle. One is impact, second is compression, third is attrition, fourth is shear. What is impact in very general sense is, I have a heavier object, I have a particle, I wanted to make even smaller of this particle. What I do is, I drop this material on this smaller particle. Because of the force, impact force on the particle, it will get crushed. It's a called single violent force application of on the particle. That's called the impact. What is compression? If I compress this particle between the two surfaces with a heavy force, it is going to get crushed or broken into smaller particle. That is called compression. Attrition means rubbing. Okay, something repeated impacts. If I have two surfaces, if particle is repeatedly hitting the surfaces and rubbing action, scrubbing action kind of, then it comes to the attrition. Okay, shear. It's a cleavage action. If I cut this material using a high shear force like a knife or something else, that comes under shear. It's a cleavage, cutting or shear forces that I am acting on this particle. In general, all the forces are present in any crusher. If I talk about any machine which is reducing the size, all the forces were present. But among these four forces, one is dominating force, rest other forces are very smaller forces. We will go into this deeper details. Imagine these are the four primary forces that are responsible for the size reduction of a material, and in any crusher or a grinder, among this force, one is in greater amount, rest are in the very small but smaller amount. But in general sense, all the forces are present in each and every crusher and a grinder. When I talk about the crushers, that means size reduction equipments, they are classified into three. One is coarser, intermediate, finer. When you are dealing with the bigger particles, then the term is called the coarser crushers. When intermediate means I am not dealing with very small particles, I am not dealing with heavy particles. In between these two sizes, I can able to get intermediate size. Okay, the three terms: coarser, intermediate, and fine. Ultra fine, I am talking about very smaller particles in microns or nanometer levels. That's called the ultra fine particles. What are the equipments used for different crushings? Example, if I talk about the bigger particles, coarser crusher, jaw crushers, gyratory crushers, and roll mill. These are the coarser crushers. When I talk about the intermediate crushers, the hammer mill, cage mill, these are the machines that comes under the intermediate crushers. When I talk about the fine, okay, crusher, ball mill, rod mill, pebble mill, okay, mainly in the ball mills, impact force is the responsible for bringing down the material. Okay, let's go, later we go into that. Ultra fine, in ultra fluidized energy mill, these are the mills used for the making of very smaller particles. And what is the choice? How I can go for the different crushers before I start making it? There are some properties, okay, because if I take any particle, I have to see its properties. Depending upon the properties, I can choose for the different kind of mills or crushers. Choice of a crusher depends on hardness, toughness, what is the structure, what is the crystalline nature, friability, ability to get fractured, that's called the friability, moisture content, if am I dealing with the very softer materials or harder materials, which comes under the moisture content. Explosive nature, that means if it is explosive nature, I cannot put heavy force on it, right? And soapiness, if it is have slippery tendency, that's called the soapiness. Crystallinity, and what kind of material, what kind of crystalline material I am dealing with. Temperature sensitivity, is the temperature going to destroy my material? That's called the temperature sensitivity. Along with this, there are few other aspects we have to look into before we choose any crusher, whether go for ball mill, hammer mill, jaw crusher, roll crusher. Input size, what size I am dealing with, feed size, what is the size? It's a 50 mm or 100 mm or 150 mm, 1000 mm, what is the size of the material? Capacity means what is the capacity of the mill? It is 1 ton per hour, 2 tons per hour, 3 tons per hour, that's called the capacity of the machine. Okay, choking tendency, among these crushers which have the more prone to choking means it won't crush, somewhere it will stop, the feed will stop and won't be further crushed, because what is the choking tendency of the machine are listed here. And power input per unit weight of product. Okay, power input, that means if I want to make 1 kg of the smaller particles, how much power I have to give it to the machine, that's called the power input per unit weight of the product. And resistance, okay, What is the resistance? That means, am I dealing with harder materials? Is it going to destroy my machine? So that's called the resistance. What is the service life? What is the service life of the different crushers I'm talking about? Low operating and maintenance. Okay, low operating cost and maintenance cost. This is also we have to look into before we choose any crusher or grinder. Or what is the safety aspects? Because different crushers and grinders comes with the different safety aspects. Because am I going to have to take extra care before I install this machine in my quarry or any other application industry, that I have to look into the safety aspects. Let us go to the lab and see what are the different machines that are available with us. And chalo. This is the Blake jaw crusher available in our laboratory, and mainly it uses the compression force to reduce the size of the particle. It has the two jaws. One is moving jaw and second is fixed jaw. If you see inside, you're gonna observe few jaws. Two jaws are there. Between those jaws the crushing will happen. See, the moment I turn the machine on, you're gonna observe the different jaws doing the purpose. Okay, see, I'm going to turn on the machine. This is the ball mill available in our laboratory, and it uses mainly impact force and compression force to crush the material. See, we have the drum and we have steel balls available with us. Okay, if you go to this particular, while the machine is turned on, this ball will go to the, and it is going to create some impact force on the material. See, I'll turn on the machine. You're gonna observe. And this is the hammer mill. Mainly it uses the attrition and shear force to compress the material. As you can observe, there are hammers. It rotates. While the shaft will rotate, these hammers will hit the material, and we're gonna pour the material on the hopper. We just close the machine. Okay, while you put the material, it goes entire into the hammer mill chamber, and it is going to rotate at very high speeds. And this is the roll crusher that is available in the laboratory. Is one of the coarser crusher. Here you can see the two rolls. It rotates. One is in you can see the two rolls. These two rolls will rotate, and if you put the material inside these rolls, it is going to crush the material. Let us see how it operates. As you can see, if you put the material onto the top, and the product will come to the bottom. This is the typical roll crusher. And this is one more machine in our lab. It's called ribbon blender. Okay, and you have the ribbons here. If you put the material and ribbons will rotate, it will mix the material whichever you wanted to mix. And this is how the ribbon mill rotates. If you put any material inside, it is going to mix the material into equal proportions. Hi students, as I have shown you the different crushers and grinders available in my laboratory, I hope you have seen what actually how the equipment looks like. In my further video, I am going to talk something about the crushing laws, because there are three different laws: kicks, bonds and rettingers. Their empirical laws comes from the experience and experiments. The empirical laws normally comes from the experience and the experiments. And because I told you about that three different coarse, intermediate, fine, ultra fine crushings, different laws applicable for different crushers. We are going to see with an example of application of laws and finding out the constants. And thank you for watching.